Have you ever stopped to think about how some of the world's great civilizations managed to thrive in the most scorching, inhospitable places on Earth? I mean, long before we had electric grids and modern AC, ancient engineers came up with these absolutely brilliant, sustainable ways to master their environment. Today, we're going to dive into one of the most ingenious systems ever created for keeping cool, a true masterpiece of ancient engineering that cracked the code of the desert.
Okay, so picture this, a bustling city right in the middle of a desert. The sun is just relentless, temperatures are soaring, and there isn't a river for miles. And yet, people here, well, they aren't just surviving, they're flourishing. They've got lush gardens, comfortable homes, and a steady supply of fresh water. Sounds pretty much impossible, right?
And that's the central riddle we're looking at. Without any pumps, power plants, or refrigeration, how on earth did they solve the two biggest problems of the desert? Finding water, and then escaping that brutal heat? Well, the answer lies in two remarkable and, as we'll see, interconnected inventions.
First things first, let's tackle the water problem. Because, you can't have a city without it. The solution, cooked up in ancient Persia about 3,000 years ago, was an absolute masterpiece of hydraulic engineering. It's called the Qanat.
The real genius of the Qanat is just how simple and effective it is. By keeping all that precious water underground, it basically eliminated evaporation, which in a hot, dry climate is everything. This design was also incredibly tough. It could survive earthquakes, even wars. But maybe the most amazing part? It uses zero energy. None. It's all powered by a perfectly calculated gentle slope using nothing but gravity.
Now, building one of these things was an epic undertaking. It required a really deep understanding of geology. Workers would find groundwater at the base of a mountain. Then they'd start digging this gently sloping tunnel, sometimes for dozens of kilometers, all the way to a city. Those vertical shafts you see, they were crucial for getting air in and hauling dirt out. And you had to get the angle just right. Too steep, and the water would erode the tunnel. Too shallow, and it just wouldn't flow. This was precision engineering, all done by hand. And the scale of these projects is just staggering. I mean, let that sink in for a second. 70 kilometers. That's an underground tunnel dug by hand to bring water across a desert. That's like walking from downtown Los Angeles all the way to Irvine, but underground and perfectly sloped. This wasn't just infrastructure, it was the literal lifeblood of an entire civilization.
Okay, so the Qanat solved the water problem. Fantastic. But what about the oppressive heat inside the buildings? For that, we need to look up from the ground to the rooftops to find the second piece of this incredible puzzle, the bad gear, or as it's more commonly known, the wind catcher.
A wind catcher is basically a chimney in reverse. It's a tall tower with openings at the top, and it's designed to do exactly what its name says, catch the wind. Now the key here is that the winds higher up are usually faster and a whole lot cooler than the hot, stagnant air you find down at street level. So the bedgear is designed to grab that good air and funnel it right down into the rooms below. The whole principle is so simple but so effective. You can see in the diagram on the left, the wind goes into the vents and gets pushed down the shaft. And then the photo on the right shows you what they actually look like, these beautiful structures in Yazd, Iran. They are, for all intents and purposes, the original zero-energy air conditioners. They're like the lungs for the entire building.
So look, each of these technologies is pretty brilliant on its own, right? The Qanat brings water, the badger brings a breeze. But the true genius, the real magic, happens when you put them together.
And that's the key question. Think about it. You've got cool water flowing in a channel under your house, and you've got this tower forcing hot, dry desert air down right on top of it. What do you think happens next?
You get one of the most powerful phenomena in thermodynamics, evaporative cooling. As that hot, dry air from the badger rushes over the cool water from the Qanat, it causes some of that water to evaporate. And for a liquid to become a vapor, it needs energy. And it steals that energy right out of the air in the form of heat. The process instantly chills the air, which then gets circulated through the whole house. And what you get is a cool, comfortable, even slightly humidified breeze. It is literally ancient air conditioning.
And it works. It really, really works. I mean, the data tells the whole story. Look at this graph. The top line, that's the scorching outside temperature, peaking in the afternoon. But that bottom line, that's the room temperature inside. It's not just cooler, it's incredibly stable. It creates a genuinely pleasant climate inside, even on the hottest of days.
This whole system was so ingenious, it wasn't just some local secret. No, this was a revolutionary idea that spread all across the ancient world, and its wisdom is something we're only now rediscovering today.
You can actually trace the journey of this idea across the globe. From its origins in Persia, the concept traveled with traders, with armies, with migrants. It went west into North Africa and Spain, where they're called gallerias. It went east along the famous Silk Road to China, where they're known as carrés. And believe it or not, it eventually even crossed the Atlantic to the Americas.
And here's the really wild part. These systems aren't just history. They're not just museum pieces. Thousands of them are still in use today, providing reliable water in places like Iran and Oman. In Afghanistan, they're actively being repaired and restored after decades of conflict. From Spain to Peru, the legacy of this ancient, sustainable tech endures. It's just a testament to how well it was designed.
And all of this brings us to a final, really important thought. In a world that's struggling with energy costs, with climate change, we are all desperately looking for low-energy, sustainable ways to live. So, is it possible that the blueprints for our future aren't in some brand new technology, but have actually been buried right under our feet? In the wisdom of the past?